Utopias, dystopias, and today's technologies hosted by Johannes Castner, bringing a global conversation discussing technologies that affect us all.
Hello and welcome. My name is Johannes and I'm the host of this show. Today I'm here with Umesh Upadhyaya and we will be talking about high performance computing in Nepal. This is a fascinating topic, I think. I am always interested in how super modern technologies are implemented around the world. And this is what this will be about. So let me introduce you to Umesh. Umesh is a co-founder of HPCNepal, and he has a bachelor's degree in electronics and communication engineering, as well as an MBA with specialization in management science and systems. He has experience working with high-performance computing systems at International Center for Integrated Mountain Development, where his involvement was with Atmosphere Initiative and SERVIR NASA projects. Mr. Upadhyaya also collects experience working with International Seabed Authority, UNDP, and Elections Commission in Nepal. Mr. Upadhyaya is a recipient of a full grant to attend international supercomputing conferences in 2017 in Germany. And he was a first recipient of inclusivity grant to attend supercomputing conference also in 2017 in the United States. Great. Let us get right into the conversation. Hello, Umesh. It is great to see you. Welcome to the show. And let me just start right away with the question how did you start, the HPC in Nepal? Well, how did that come about, and what is the process basically that you went through to install the first high-performance computing cluster or computing system? I'm not even sure if it's a cluster in Nepal.
Hi, Johannes. Thank you so much for a lot of information that you've collected about me. High performance computing was an exciting arena for me when I started my in mid of my IT career. And then I figured it out. The scientists and the researchers, they do use big models in using supercomputers. And then there was this small cluster that I worked in one of the organizations, and the scientists were always were more focused in research areas related to weather forecast, environment modeling, and sort of things. So I worked there as a system administrator, providing support to the researchers, the domain people who used those supercomputers. It wasn't a big, as we talk about the big industry, it was very small, a number of clusters, probably 10. I think it was 10. And then sort of working on that.
Where was this? Where was that located?
This was in Nepal itself.
Okay.
Yeah.
So they already existed. So they already
Yes.
had some high-performance computer clusters. Was that at the
Yes.
university?
No, it was in one of the organizations. It was International Center for Integrated Mountain Development. So that was the organization where I worked, and they had a small cluster.
I see.
And so that was where I first knew about supercomputers and how they function. And then after working for a few years there, and then going abroad and then coming back, there was also a news that came like Nepal is going to have its own supercomputing facility at the university level. CERN, as you know, they donated a lot of hardwares to Kathmandu University, and then I had got an opportunity to volunteer at Kathmandu University to install some softwares to configure those hardwares, and it was pretty much exciting time for me. while doing that, and prior to that also, I had envisioned like maybe it's a great idea to start a project relating to supercomputers, because many Nepalese don't know the fact what a supercomputer is, and how to get started over it. And then I had international community, international visits that I made during that period, and that actually gave me a lot of insights on how supercomputer in other worlds started. And then I formed this non-profit organization called HPC Nepal, and since then we're working not to a larger scale. We're hoping some bigger things are coming up on our way, but yes, we're working into some domains in the high performance computing part.
Yeah, this is great. I have a question there. So it says on your website that CERN also invested in you, or gave you hardware, or how did that work, and how did that come about?
So I cannot say pretty much on the overall process, but I got that news. We did not receive that hardware. It was the university, Kathmandu University at Nepal, which received the hardware. So we do not have, as an HPC Nepal, we do not have our own hardware systems. But yes, we do some research on our own, and then we use our own, small environment where we sort of train out people and then do some pretty much basic works on a supercomputer. But we are yet to get some more news coming up on how we will be functioning more on probably this year or next year on use of supercomputers.
How long have you been around again? What was your founding year? When did you find the HPC Nepal?
So I think it has been 4 years now.
So what is a super? So okay, you mentioned also the word supercomputer, which is a bit different from high performance computing. I'm assuming these are related terms. I'm assuming. Could you explain, maybe to the audience and to myself also, what is the difference between these two terms? Are they interchangeably used, or do you use them interchangeably, or is there a distinction? And then also, what can you not do without it? Is there so basically, what are the use cases that are specific to doing high performance computing or supercomputing?
Okay, so as per my understanding, what the matter of fact is, like, the high performance computing is any computers that uses a massive sets of data sets, unlike the use of laptops or any other such desktop devices that we can use such big data and then manipulate to get that output, is where we call that high performance computing system. These terms are quite interchangeably used in the industry, and it's for me it's very much of a context where I use supercomputing and high performance computing mostly, quite often related to the matter of fact that how we use it and how the industry explains it, more of that kind. But to that extent, where probably how we use high performance computing or supercomputing words, actually, I have not gone to the depth of that matter on the difference between that. Just like I said, I use that quite interchangeably on that. So for HPC Nepal, one of the use case that we're using currently is the use of high performance computing for weather research and forecast. The universities here and research organizations, they do use HPC systems in Nepal for weather forecast. There isn't big industries as such, but of course there are a lot of use cases that we can work on here. Mm, Currently, what we are doing is how to commercially use the old mobile phones, Android and the iPhones, how we could leverage their CPUs or GPUs, and then maybe use them as a high performance computing part, or how we could use that. Of course, there are few research that has been done, And the recent one was also conducted, and one of the universities in Russia actually has already conducted, and it's a very successful as well. It has already been done. If you look into Boeing systems, ZT at home, or sort of other things, they already have done such volunteering computing for flood forecasting and many others. So we're trying to do that, but yeah, we're still progressing, and then we're still in the feasibility part where we could do that or not. So that's the current situation where we are working, especially with the use of high performance computing.
So how does it compare with working in the cloud, for example? For example, is the Google cloud not available, or the AWS cloud not available in Nepal? Because these seem to be also high performance systems, right? Because I can do massive computations on those clouds. That's how I guess been using high performance computing. So I wonder, is that available in Nepal, or is that not available? And is that the issue? Or yeah, could you speak on this comparison between cloud and high performance a little bit?
Yes. So in Nepal, like the high performance computing cloud, especially the facilities, they have not been used by much industries or research organization. It's available. You can use Google Cloud and AWS, but the fact that Nepal has to have its own homegrown facility, one of the facility for HPC, is actually a must needed part, because we're in the domain sector. If you look into, there are so many sectors like hydroelectricity. Nepal is very prone to earthquakes. So that homegrown industry is itself needed. And of course, on the cloud level, if you look into it, that might come as more of a expense to the industry here, because the research domain hasn't scaled up to that part where we could use the cloud features. So I think starting from small clusters and going forth on that arena would be better. But yes, use of cloud is limited to non-HPC sectors, but it hasn't been used to the HPC part.
And why is that again? I'm sorry, I don't understand. Why is the cloud not applicable, or can it not be used for high performance computing just across the board? Why does Nepal need its own one? What's the advantage of having your own?
Yeah, I mean, like there are a lot of advantages of having our own supercomputers as such, and then there are also reasons behind the, cross data, the cross-border datas that we might not be able to be applicable to cloud platforms. We could be using the data in the homegrown supercomputers. Also, the fact that many Nepalese people, or many technology, or many researchers, yes, do not know how to use the cloud. The cloud industry is not so large enough that they use, and then the frequent trainings might be needed to use that, and that would also add additional cost on bringing using the cloud and others. Also, there are some policies that does not let the US dollars of the economy to go abroad. There are some policy restrictions in Nepal. So that will not allow, that will, I mean, like that is as a problem where you cannot pay as much as you want for the cloud. There are some restrictions with that. So that would be one of the reasons as well.
That makes a lot of sense, actually. So let me ask you a question about on the website it says a lot about Nepal's participation in global supercomputing conferences. What are the key takeaways from those, and how have they been applied thus far in Nepal already?
Okay, so Nepal, as a matter of fact, if we look into China and India, they have massive use of supercomputer use cases, and they do have. They're also growing very large in terms of exascale, or use cases, various use cases. They have multiple universities where they are using supercomputers, and they have also been listed in top 500. And that sort of, we being in the middle of that big technology giants, actually, there's a thought process that we also might need, and then use it to our extent, to what extent we can go and learn from these countries, and then create values on our own on how we could use supercomputers on that part. uh, so I think, yeah, that's the most. And then the other part is, like, there are so many international Nepalese. There are Nepalese people, researchers and scientists abroad doing research and sort of their own work in high performance computing system. So they want to contribute to Nepal in some way where that could be more effective, uh, where they could be, they could provide some volunteer support to community support, or in research domains where they could be helpful. So I had connected with those kind of network as well. And the international communities also are so helpful in providing trainings. And then there is also exceed, and then resource where they try to provide to certain support services to the resource constrained environment, like Nepal in terms of HPC. And these communities have evolved so much, and I have been connected with them. So I got quite a few trainings as well on that part. In Nepal, we are also training few people on HPC, and then right now we're also doing some work on how we could leverage the use of mobile devices for supercomputing, for use of HPC. So these things have actually happened with us, and there is also other international communities who want to tie up further with us, give us some work to get started, and that's happening pretty much soon. Yeah, that has come as a possibility so far.
That's really sounds great. I had a guest on my show recently, a few weeks ago, named Ananya Agrawal, and she was speaking. She actually is in India, but also in the Himalayas. She worked in the Himalayas in villages where she was delivering very innovative learning solutions via very low tech devices. So these people didn't have even smartphones, but they had some kind of, you could say, dumb phones, right? So they could call some numbers, and then they were sort of connected with this learning system that she describes. And and the learning was all about opening businesses and starting things, and developing and innovating from materials, even all the way. So I'm interested in this low tech solution as well, and how it might be connected to high computing performances in the cloud or somewhere else, right? So maybe people have like these little phones, and they could interact with a high performance computer. Is that something that's possible? And then how is it used for education versus research? You speak a lot about research and so on, but what about all the way down to the lowest level of education? Are there some applications of high performance computing that you can see, either how people learn, how it affects their learning, or what they learn even?
Yes, I mean, like, on the smaller scale, we do have like Raspberry Pis, and then sort of those devices that can be used. And one of the universities in UK, I think they also use those Raspberry Pis to build a cluster. And it's great always to see in supercomputing conferences also that people have been using those small devices, and then readily used it for a lot of things, including one of the areas always, like I'm mentioning, is the weather forecast, because that's the domain where Nepal is using it, and I'm more fascinating with it. Having said that, yes, like the small smartphone devices can be used, but we've not pretty much aware on whether that phone could be those phone could be used for parallel processing part. Rather, they would use the distributed computing, which is different from what high performance computing normally do. But as a matter of fact, yes, those phones could be also used, but that has to be, we're still doing research on that, and there are international communities also supporting on that if it's possible. There are a few other universities that we are in communication with, and if that's a possibility, that's another part. But yeah, on the educational small K-12 students or students level, what we could do is, use the laptop itself. There are containerization systems, right, like the Docker and all sort of things that can be used even with high performance computing. So we can bring that whole data center to a small laptops, collection of laptops, or the laptops itself. We could do it. The other I mentioned already, like the Raspberry Pis, and then phone systems could also be used. Yes, there are these are the various ways we could work on it, and I think we have set a few plans. I can only tell you what happens, like maybe within a year, what we will be doing on that part. So yeah, that's it.
Great. Yeah, I gotta have you back for that then. When you have when you're further along your journey. But so let me ask you. This is all. Could you get a little bit more into the details as to, for example, how do you use supercomputing for example, weather forecasting? How does that actually work? So just so that I and the listeners at home have a bit of a sense of how that works in practice.
Okay, so first, you have a few clusters of hardware. Then you set up that using any open source tools, like operating system, like the readily available ones. You could use CentOS, which probably not anymore, but you could use Rocky Linux or any sort of freely available operating systems. And then on top of that, there are certain HPC tools that you can install. And then you can install the weather forecast application on that part. And on the visualization part, you could work on how to get that visualization part. For the data part, you will readily get those data available in NASA websites and other satellite data. You can readily get those. So you can get that data readily from websites, a lot of available sites, and then you can use that, install the application, and get the data that you want for the weather forecast. For that domain knowledge, for weather experts, we might need weather experts, weather forecast experts who are more into that, more have a more profound knowledge on the weather systems, how it works. But on the installation and configuration part, it's mostly the system administration parts, which can collaboratively working on it. We could as a matter of fact, so we could also select a domain area for Nepal or for mountainous region, and then we can do some predictions over a period of time, like 6 kilometers to 12 kilometers, or and then the time range of that, and then run a forecast on that.
So is there any AI involved in this at all?
Yeah, the industry actually gives a lot insights into the AI and ML part, but we haven't. I'm not much aware, and then we haven't used that so far for our context.
I had my long-term mentor Neville Nui on last week, and we were talking a bit about the evolution of artificial intelligence and computing, and he was addressing this very famous, very well-known rule of computing, which is called Moore's law, where the computing power doubles every so often, and it really kind of is an exponentially growing factor, this computing power. Has that affected your work at all? Is this like something you have sensed and seen within your span of working with high performance computing? How does it affect high performance computing in general or supercomputers? Could you speak on that?
Um, I think in as per my knowledge, what I think is like since Moore's law is pretty much not very practical now, and then we're moving that curve pretty much higher than what we actually learned previously. What I see is like everything, including AI, machine learning, deep learning, whatever it is, are all converging to the high performance computing system. Or maybe they will get converged to other kind of HPC systems, or maybe for future systems that we do not know what we call right now, talking about quantum and all sort of things. But I think the convergence is all there. And while that convergence happens, I think the use of CPUs and the use of GPUs, and when we're talking about petaflops and to that level of large scale data and all sort of things, I think this is going to be very much a game business where people sort of the industry is in a competition mode on how to get into bigger on a larger domains of work, and how to improve the processing capacities and all. But for sectors like small and medium enterprises or other part, there are possibilities where we could explore the grid computing, for example. So the grid computing would mean we could use uh, the servers, old devices, mobile devices, servers, laptops, tablets, or any desktop computers for that matter, anything, and then come with an architecture which would leverage the need of users at all levels. For example, the big supercomputers could also be used. The lower scale, Raspberry Pis could be used. The laptop phones could be used, and then so I think that harnessing of that green computing would also equally be coming up in future, and that would add more to the use of supercomputers in how we could use in the low scale devices to the higher level of devices that you currently we're using.
This is kind of related to the Internet of Things in some ways, right? How does that factor in there? Is there a connection to that area?
What I think is like with IoT, we will be getting a lot of informations and data, and ultimately, when we're doing a lot of calculations, um, some might need very memory intensive calculations, some might not need that. So based on that parameters, yeah, I mean like we IoT devices, um, yeah, I mean like these kind of devices will be used to generate the data that's actually used for that we will be using with lot of tools, and then using the supercomputer more and then simulation models, we will come out with output, maybe on a bigger scale, on a larger scale that we have been doing, and that will also generate bigger capabilities on how we might you further go on implementing supercomputers. And I think that's what will drive the industry and then the current scenario further. Yeah, I mean the IoT devices as such, like you said, the mobile devices could be used for data collection mostly.
So let me then ask you a bit about something different. Could you tell me a bit about your experience working with government organizations and UN agencies? Has that influenced your work a great deal at HPC Nepal?
Mm, right now, not very much. Yes, we with the UN agencies, and then with the government sector that I worked, it was mostly on the IT support part rather than on the HPC part. I did not work there with the HPC. And yes, we're somehow tying up with government organizations to install and then configure their system, probably train them further on how to use the HPC systems. But yeah, I think that's pretty much it for now. We haven't scaled on further, but yes, on a university level we have done some as HPC Nepal has done some understanding. We have done some collaborations where we will be guiding the supporting the university on installing and configuration of supercomputing, providing them trainings when applicable. So those sort of things are there.
So this is part of your bigger mission also, right? And also there is a, on LinkedIn it's also you're talking about the enormous potential that computational research can bring to young people and to young brains of society, as you put it. Could you tell me a bit about that? Is there already something you're working on, or is this just a part of a bigger vision? And how do you connect what you're doing now to this vision? Could you speak on that a bit?
Yes, sure. So what we are doing currently is not much to a bigger scale at the university level. Yes, few people on the university level, we train them and we have done some research. So yeah, I mean, like the truth is, like, many universities or institutes in Nepal do not know much on the use of high performance computing systems or high performance computing system itself. And what we thought was like, the undergraduates or the graduates at technical colleges, they will have to produce some master level thesis or dissertations for that matter. And we have a plan to go to them and approach them on the use of supercomputers, and then probably they could come up with an idea, and then we sort of gather those people on that similar domains and then help them on the scientific part, so that they do the part on the technology front, and then come up with something that will help the industry, that will help the university, and it will also groom up that HPC level, the education level quality as well. But since like I said, like, the industry is not ready for it, because the industry does not cater to the HPC thing here. So probably that would be an agenda, because many Nepalese, after undergrad or graduate, they go abroad for work or for further studies. So that might be the case. But that, having said that, that would be a larger vision for us for right now, because we do, as HPC Nepal, we do not own our own supercomputing facility, but we are on that. Discussion with one of the. I cannot disclose you right here currently, but we are still in the discussion. And once we have that small cluster or setup of our own, then we will come up with. We will have joint ventures with a lot of universities, institutes, and then further on the development of the program, how we can go about it.
Are there, this is a little bit of a different question, not related to the last one really, but more related to Nepal and India and these areas where there are a lot of mountains. Is there anything very specific? Are there unique challenges that you have to overcome because of the terrain that you're in? Or are there also benefits perhaps of being up in the mountains?
I think I see there are a lot of benefits actually. Benefits in the sense that these high altitudes, in terms of technology, if you're looking into, yeah, I mean, the cooling facility is already there. We don't have to cool much anymore. On the non-technical part, yes, the development work might need, it would be a challenge to pull up wires to that place. People, the livelihoods would be like the ecosystem, the livelihoods would be like really challenging on those parts, those fields. If you look into the energy sectors, these mountains actually bring a lot of hydropower. So Nepal itself is very rich in hydropower. So in terms of energy, if you look into it, so a lot of data centers actually can come here, and and leverage that hydroelectricity power, which is more cheaper in many ways than using the other sources of energy, because it's completely a green energy. It comes from the mountains, and the use case itself, for the weather forecast part is also one of the domains, because in Himalayas many people go for trekking, and then there are terrains areas where pilots might have a challenge uh, for the flights and all. So I think that's more of a kind that's needed. One of the areas, yeah.
Oh, I understand. That makes a lot of sense. Also,
Mhm.
climate change, probably, right? So the longer
Yes.
run, because it's different from weather. Really, it's the climate is a bit sort of an aggregate weather, I guess.
On the climate modeling, I think it's climate research. I think it's mostly, yeah, rather than at a country scale, it's more of a regional scale that can be done. Uh, like the whole Himalayan ranges. The coverage that most countries take part in, like India, Bhutan, China, Nepal, and other countries as well. So at a regional scale, the climate modeling as such. I think that this has been going on, and then yeah, that's a great area to work on, and that's much needed actually.
Oh yeah. And do you cooperate with other countries easily? Is Nepal in good relations with India and China?
Yeah, based on based on what we've seen so far, yeah, that's the whole story of it. Yes, technologically, yes. If you look into technology domains and all the sectors, yeah, I think we're very much in a very geographically also very close, and then very much knowledge sharing, you know, uh, areas between the countries.
Well, so and in terms of digital inclusion, this is a concept. When a lot of people have no access to computing in general, right? Is there a way that you can see how, for example, something like Ananya Agrawal's work on low tech computing or low tech work can give people access somehow to to systems that may not actually be on their little low tech device, but be somewhere else, right? So that they can be connected to them and be included, even though maybe they don't have a lot of money or a lot of even maybe infrastructure that allows them to do computing directly where they are.
Mm. Okay, I think yeah, yeah. Like I haven't heard about her journey as such. I'll have to do some research on what she has done more, and then maybe I can talk about it if it's a possibility. But yes, on the small scale devices, like you said, yes, there could be small labs that might be working at schools, at institutions, small institutions, which provide the data, which can feed, collect data and then provide to a larger set of cluster computing environment, so that computing can happen there. Yes, probably this set of IoT devices or data sets can leverage a lot of data that might need in terms of use case relating to the socioeconomic aspects as well, because that's also a domain where HPC can be used, or even for non-HPC, any technologies for that matter. But as I see, yeah, low-tech devices, preferably. I'm not an IoT expert, but yeah, for devices. Could be used, could be better used for data, getting the
Well,
information collected.
also, I'm also thinking, for the minds themselves, right? So if you have humans in the loop in a way, they can learn something. For example, is it possible, for example, for someone, do you think it would be possible for someone to learn something about high performance computing from a low tech device? You see, if you attach them to some cluster, they could maybe explore how it works or learn something about it. Do you think that is possible?
That is pretty much possible, actually. Okay, so yeah, that is possible, as I see, for based on what the technology offers. That's what like I said, we're doing some research on. Um, uh, on the on using that for what kind of use case has to be identified first, because not use every use case can be run probably, or not every applications can be run over their mobile devices. Yes, a generic use case might be very much handy, and then we can probably train people on a lower level of scale on how that can be leveraged into, used over mobile devices or IoT devices. And then they might have an insight on how the HPC systems work or supercomputer work on a larger scale. Just an insight would be a great to get started somewhere, right? Yeah.
And so then, in general, do you have like a sense of, there's this concept now that goes around the world. It's called humans in the loop, right? So it's basically not just computers that you can use, but you can use human labor or some human activities to process something bigger, right? So, for example, it even goes back to a very long time ago when the Second World War was fought and the English were fighting against the Nazis in Normandy. So they would attack the beach, and they would know exactly what the beach was like because there were vacationers that were there before that took millions of pictures of the beach where they were hanging out and where they were vacationing. So British vacationers before the war had taken photos of little sections of the beach, millions of them, and they had sent them into the BBC. And you could think of this as a calculation, right? So it's like to understand the beach, you have these people sending in pictures. So this is just a very old application. Now we talk about collective intelligence, and there's many applications. Do you find that in Nepal as well? Do you have a sense of that where humans can be part of the computation in some way?
Um, I think yes. If you look into the collectivism or the collective intelligence, I think the whole network of humans are a part of it. Just not Nepal, but the whole world should be a part of it. If you look into it, that and what our society, our Eastern society, provides here, and then what the West provides. I think that there should be a merge between that, and then come up with that information which gives us more insights, or which can be used as the more to generate more intelligence, just not the data, just not the information, but that could harness more intelligence, and then that could be used for the better of the humanity. I think possibly yes, in terms of I would want to give an example on that part, where mostly if we look into people here, we did not have weather forecasts, or in generally previous people 100 years back or 200 years back, people did not know about weather forecasts, but I have heard that they had insights that tomorrow it is going to rain or day after it's going to rain based on their observations of what's going on around. So I think those information comes from their, yeah, I think those informations comes from their one of the insights, and also on the work that they were doing every day on the fields, also on the animals behavior and how that was happening, and maybe they forecasted on the weather on what it would be in a couple of days, or maybe one day, right? So I think I mean, there are so many sectors we could use those kind of observation that we have completely missed, using nature's using the natural part, just not the artificial intelligence but the natural intelligence that's already there. I think that part is what makes the collective intelligence more exciting, right? So I think humans can be a part, even in Nepal if you look into
Yeah,
it.
I think there's also a flip side to this, right? So the fact that we do weather forecasting, or even on your Google, like we in the West, I don't know if you do it in Nepal, but we have Google Maps, right? And if we drive from one place to another place, we know exactly when we get there and so on, right? I think in some ways it might have reduced our own intelligence a little bit, because we
Yes.
now rely on this intelligence, this kind of artificial intelligence, and we just rely on it and we turn off our own thinking in a way. Do you see this as a potential problem? And do you think that there's something we can do about this problem? That we also.
Um, yes, I think. Yeah, I think. I think when we're talking completely on the artificial part, we've completely we should not be missing the natural part of it, because the artificial word itself comes completely from the opposite of what natural is, right? So I think. What nature provides, what brings us, we as a human beings or as an animals, I think those parts of things should not be missed when we're talking about artificial intelligence. We should not be just talking about programming. We should not be just talking about robots, as a matter of fact, or software tools or anything. But we should also come into the ground level of that humanity, where how the process of we being born, the culture we grew up on, and how our grandfathers or forefathers worked, what were their needs, and how that information today has impacted the world, and what it could lead further for artificial. I think those kind of merge in those kind of things, if we can bring uh, together, like that convergence, if we can bring, I think artificial intelligence can be of a big possibility for humanity in future. But if we look only on the aspects of the technology part, well, it might provide a lot of information, a lot of insights, and maybe we could also struggle with what is true versus what is false. But but yes, overall, what technology today is providing is magnificent. If you look into it, if you stay in home, while staying in home, we are having everything in a gadget. But I think we should also look into the unlearning process of our previous people, because they did not have much to learn. They just had opportunity or quite a possibility to observe. So when that observation happens, what could we benefit
Yeah,
of
yeah,
that?
absolutely. I agree 100%. And I also think that maybe you have an advantage. You see, what makes me think then, when you say these things, it makes me think that maybe Nepal has an advantage over, say, America, because in the US we're already so far into the artificial. We've started so early. Now we're we've already had many generations of, well, many generations, not really, but we've already gotten so accustomed to it. And maybe this did not yet happen in Nepal, and you can learn something from this before it happens to you, in a way. That to complement the artificial with the natural in a better way than we have done, because I feel like a lot of, for example, Facebook, they advertise to us, and we spend our time on it, right? And we waste our time really on it. And those kinds of things, they actually make us a little bit dumber. There's this artificial intelligence that is actually causing us to become dumber, dumb us down, really. So maybe people in Nepal, and people in places that haven't had Facebook for as long as we had, and haven't had the internet even as long as we had, maybe they can look at us and say, maybe not exactly like that. Maybe something a little bit different. Maybe we can learn something from this. Do you think there is something to that?
No, actually, we actually, maybe in internet we were a bit lagged, but I think on Facebook we were pretty much similar times, as far as my knowledge is there.
Uh,
So yeah, I think one sector which needs to be looked at more profoundly is uh, what medicines bring about. Like, for everything we now pop up a medicine, for that matter, like anything happens. But what east, or what we talked about, was more of an ayurveda. The ayurveda word itself, it means like how we can, it's a study of the age. The word itself does not talk anything about the disease, but right now medicines are talking about how we can treat disease. It's already, the word itself, it's already coming from age to disease, and how you can cure. But if you look into the ayurveda part, the word itself means how we can increase our age, which means we are going to have a better health. How can we have a better health? So I think that's a domain where uh, a lot of research can be done on plant-based, medicines mostly. So that's where I think um, East can bring a lot of insights, and maybe the books, the old books, or a lot of knowledge base that we can bring, and then that can also be leveraged over HPC systems, high performance computing systems, on how we can use it for humanity to increase the age or benefit for their health.
That's a wonderful idea. So I really love this idea of combining traditional wisdom with modern technologies and modern insights. I think that's a really great thing in general. And I think that definitely in Nepal and India has a lot to offer in this regard. I've eaten Ayurvedic food and it is fantastic. It's traditional Ayurvedic food, even without any modern addition to it. And it is fantastic. It is really good. It feels good in the stomach. It feels, you feel good after you eat it.
Even the food, right? So I have like for example, it's a fact that what our grandfathers ate, the minerals, the amount of vitamins, the minerals that one orange had. So if we eat it 10 oranges now, so we get actually the same kind of vitamins that was there only in one. So we have to eat 10 oranges for now. But what we know is the fact is that, the same orange is coming, but we do not have an idea on the amount of vitamins, the minerals that it carries, right? So those sort of inventions or research has not been done so far.
Do you see
Lowering,
this as a use case for H?
yeah, I mean, like we should know if we're eating the right kind of, and just not the right kind of fruit. I think most fruits are the right kind, but the fruit that we eat actually also should have a certain level of vitamins, a certain level of minerals, and whatever. Uh, so maybe we could calculate based on the soil fertility, or based on the use of agricultural, the kind of type of soils, the type of fertilizers being used in the soil, and whether that fruit, the product, agricultural product that's coming up, versus on the organic level, what is the differences in terms of even the values of the minerals or the vitamins. And if it's just the fruit with no value at all, it's useless to eat. Just saying the fruit makes you healthy, right? So there are a lot of factors
Yeah.
that could be looked into.
This actually points to a potential for a much greater scientific approach to how we eat and how we exercise. You could really turn our entire life in a sense into some sort of laboratory, right? You could really figure out what we should do at all times, how long we should sit in front of the computer, if maybe we should start standing after some time. And you could really extend what you just said to almost every aspect of our life, right? Where we can really have a good understanding of what are the things that causing us pain, for example. If I sit in front of a computer in a particular way, if I change it a little bit, if I raise the desk a little bit, maybe the pain will be lesser, right? So, and all of these things could be systematically studied, right? So right now, it's all relies on our intuition or on our feeling and our own self, or like tracking things we do and we don't do and how we feel. But this could be, done also on a large number of people, so that we really have a good sense of what works and what doesn't work in everyday life. Or we haven't even really begun to crack this open. Is that right? Do you see that as well?
Yeah, I mean, yeah, I see that what you're saying actually makes a lot of sense. um, yeah, I mean, like we could go on that journey of data itself, but yeah, on the bigger aspect, what we need to look is how it can bring well-being to people. Because if anything that we do is bringing well-being to them, whether it's working on the computer, or if they're sleeping like 4 to 5 hours, and even 8 hours, for that matter. Yeah, if a person sleeps for 8 hours is a fact that has given to us, but it might as well be possible that a person sleeping for 3 to 4 hours is more healthier than a person sleeping for 8 hours. But there could be other things, that could be looked at, whether what is making such differences and what is the need of that particular person, because it varies. And maybe that could be enhanced in terms of, we here practice those things as yoga, like the certain exercise or yoga practices. That's more, and then meditation
Yes,
techniques maybe.
I know, I know.
Yeah, I mean, like, yeah, I mean, you could also.
You might be interested to hear. I don't know what it was, but one of those years, I read in a business magazine that yoga studios were the fastest growing business in America. So
Wow.
that's that's your influence. That is the Eastern influence on the U.S.
Uh,
So there is. I don't know if this is true every year or if it's always true, but it was at least once the case
yeah,
that yoga studios were very fast growing, the fastest growing business in the U.S. So
yeah. I mean,
that's an
I
interesting
had.
fact, and we have it here in England. We have it in Germany.
Yeah, I mean, I had read one article which said like, what is going to happen if AI takes over everything, every jobs and every vocation practices that has been doing. And then one of the articles said that, well, if people have, if everything is taken care on their work or studies, then the only thing they could do is sit and practice meditations or do some yoga practices, because when everything has been figured it out, it's time that they do such practices. So yeah, I mean, like, it was pretty interesting on that part.
And music, I think, but that's
Yeah, of course. Yes.
music and art. I think I don't think that
I
music and
mean,
art should be done by AI. It doesn't make any sense. It
but do
doesn't
you
make
think?
any sense.
But do you think it's not? It's happening already, right? Even the
Yeah,
music,
yeah. But I can't
even
listen to it.
even
It doesn't make
poems.
so far.
Yeah, even poems and
Yeah,
everything.
it's true that it's happening, but I don't see. I still don't see the value of it myself personally. I feel that music is something that we do. It's like almost. I feel that if you see yoga robots, you start saying, okay, it exists. You can make it. You can build robots that do yoga, but I don't know what it means. The meaning is a bit elusive to me.
Right. Yeah.
So yeah, no, this is great. I really enjoy this conversation, and I think that there's a lot that you are doing in Nepal. That I think it's interesting that you're doing high performance computing in Nepal. I mean,
Mhm.
this is I wouldn't have thought that that the need is there. How many people are in Nepal? Could you give me that, because that would be an interesting fact for people who don't know this to relate to the whole story.
Just, I mean, let me check that out. Yeah. So exact is 30.03 million. 2021 census says that. Yeah, it's very. It's like, there are city areas where more people are there, and then especially in the mountainous areas there is very less. So 75% of our land is mostly hilly areas, big hills, and then we have lots of forests, and then, yeah, I mean, like, the city areas are less, the agricultural land and city areas are less. So it's sort of like, um, the culture is very diverse, the people are segregated, but mostly the density is on the city areas, I would say.
Mhm.
The hilly areas and mountain
So
areas are.
diverse, like there are a lot of different cultures.
Yes.
So what is the mix? What does it feel like? So when you're, let's say you're in Kathmandu, yeah.
uh,
So there is probably the biggest city, I would assume.
yeah. Yeah, I mean, like, it's a valley. There's a Kathmandu, Bhaktapur, and Lalitpur. Yes, it's a quite small city actually.
Yeah. So this diversity in the young is it a relatively young country? I think it's also quite a young country, right? Compared to, for example, China is aging very fast, right? We know this. There's this demographic eclipse or cliff that we're speaking of when we're talking about China, because of the one-child policy for many years, right? And there is this, aging population basically. India is a bit less like that. So now I'm wondering, to what degree are you, is what is the age structure of Nepal? Because this, I think, will make a big difference with respect to high performance computing, who gets online, right? How many people will be there in the future?
Mhm.
Is it a growing population, or is it already a shrinking population?
Yes, it's a growing population, especially if you look into youth. The youth carry the major population of the country. Um, and then a lot of youth actually travel abroad for their studies. Um, if you look into the IT sector, the IT sector is growing very big here, and with the current change in policies, where work from abroad, there are certain policy changes that has come about for bringing in bigger markets to Nepal. So the government has made such policies, and then there is big companies as well coming to Nepal and working here, outsourcing their work jobs here. A lot of people are working on AI and ML and mention not other areas of technology as well. There are training institutes. There are a lot of graduates coming out of technology institutes, and a lot of people that have gone abroad are serving here. And the international community, like for example, HPC Nepal and other research institutes, are also driving that force ahead. So yeah, it's a growing population. The youths are our energy, we should say. Yeah.
So you're sitting between one country that's kind of shrinking and one country that I think is overall maybe stabilizing. I would say India, it seems to me, is starting to stabilize, and so you're still a growing population. How is that with economic growth? What is your economic growth looking like?
Yeah, the economic growth is better. Of course, the COVID situations led to some problems, but we're reviving again on that. So the government has come with a lot of policy reforms on how to increase the economy growth, and bringing in lot of, like I said, a lot of IT sector jobs to markets to Nepal, um, and then increasing the industry here itself on the technology parts. Uh, there are industry, actually manufacturing industry also is growing here. Some manufacturing, some car and some bike manufacturing companies. But it's mostly on the technical, and also the one of the biggest is the tourism, and now it is going to be, in very few years, it's going to be the energy sector, the green energy, the hydropower energy, because and the country's plans to sell it to India, to the neighboring countries, to India, China, and Bangladesh. Yeah, in few years there is going to be very much or abundant with hydroelectricity. What Nepal will be consuming versus the level of production is, it's going to be very large. So there will be a lot of green energy for and it would be a great news for the industry. Like we're talking about blockchain industries, we're talking about supercomputers, we're talking about quantum computing. These are going to take enormous amount of energies. So yeah, I mean, with energy sector, if you look into, Nepal could be a platform or place where people can start off with bringing at least look into that aspects or prospects, or a possibility, if this could be a place of area to work on and bring in technology. And also, when we're looking at the green computing part, I think that's essential even for the what's happening globally in terms of climate or weather.
So you could do a lot more computing. Let's say you could move some computing from a more polluted area, or from an area where electricity is more polluting, to Nepal, so
Yes.
that the computations that are being done are less polluting, right? So that is actually
Yeah.
a really interesting prospect for Nepal, it seems.
Yes.
Yeah.
Yes. That's very
Okay, so you're becoming really kind of a high tech society then. So you're moving from a mostly tourist driven society to then a more high tech society. But at the same time, probably you want to preserve also the tourism, because that's obviously, you
true.
have a beautiful country, everybody wants to see it, you don't want to trash it. Right? So
Yeah, that's very much true. Yeah.
so it's a delicate balance, right? Because
Yeah.
in California, for example, we lost 95% of wildlife. It's a lot of the wildlife was lost and is really 95% or 90% of wildlife. It still has a lot of wildlife, so it's incredible when you think about what there was, what there must have been before it all started. So I think you would be very well off not to repeat that, in your country, because Nepal is one of the most beautiful places on earth. I know about that. I had friends who went there, and
Mhm.
so safeguard that. And maybe you can use AI and even high
Sure.
performance computing for the tourist industry as well. Do you think that there are some applications in that area?
Um, I actually see a lot of potential in that area, especially when we look into the tourism 4.0 concept. The tourism 4.0 concept is a concept that brings in all kind of blockchain, artificial intelligence, machine learning, and then other tools on how to uh, better or for the betterment of the tourism industry or the tourism market. Mm, I think that would mean like we had a massive earthquake uh, a few years back, and then that led to a lot of disaster to the to a lot of old heritage sites and buildings, and preserving them has been one of the challenges, but still they're being rebuilt. So I think having these kind of places, these heritages, um, taking the 3D images of them, also evaluating on what time they were built, or what kind of bricks, or what kind of labors were being used, sort of those datas, and the availability of datas, those kind of data would mean like we could prevent from building a concrete wall, and then going further down we could also bring those heritages back to life as they looked previously, how they were. So one area could be using those 3D models on preserving those tourism heritage sites. The other could be like the data itself is enough, I guess. For example, so on the mountainous region, if you look into that, people come here for trekking and then all sort of things, and then making that into a big market size economy, and then using the virtual realities and then sort of things to actually for people to take that adventure when they do not, so many people might not be able to travel to mountains, but they want to experience that with a virtual reality, probably, right? And also experience Nepal, the scenes around the valley, and then maybe go somewhere virtually. So I think that landscape, all sort of the data, imagery data, would really help in bring that or uplift the tourism industry. I think that would be an area where artificial intelligence or use of high performance computing would be really need to looking further into.
Fantastic. So, so a lot of different applications. Also, probably in combating if something, for example, God forbid, something like COVID-19 were to happen again, to trace people who are affected from and so on. That is also a big application, right? For supercomputing and artificial intelligence. Actually, in fact.
Yeah, I think that was done by a lot of industries all over the world. In Kathmandu University supercomputer also, they had done some research regarding the COVID one. So Amazon also had supported for us on this part. Actually, they provided some cloud computing platform for us, and then the university did actually some research on it. So yeah, things like that, the pandemic itself, and then a lot of areas of the climate change, and simulations for earthquake, and then like you mentioned California, maybe the forest fire itself, right? Also playing that role where we could use supercomputers on how we could reduce the forest fires, and then overall, using this data to uplift the human well-being inspiring people further. I think that's the most important thing that we can bring further.
So let me ask you one more question with regards to technologies. Do you see that there's an interaction between, say, the blockchain, because you mentioned the blockchain earlier, and supercomputing, and maybe the metaverse and supercomputing? Do you see that there are some connections there? I mean, you were speaking about tourism and landscape recreation. I
I
suppose
think
that takes a lot of computing, right, to put someone into these places.
I think on a competing level, yes, there could be, but I have not done much research over metaverse and such, so I cannot say what would be the scenario. But definitely yes, because those applications would definitely be highly memory intensive or process intensive applications that will be used, and users will always need better output. And if we're not running it in high performance computing platforms or some other high end systems, then it's going to be very slow and users are not going to use those anymore. And when we're talking about these things, these are going to generate a lot of amount of data. So if you're just talking a lot of amount of data, the big data, the chunk size and all sort of things, then yeah, I cannot say to a point where this would be the use case and this is the scenario where we would be using. But I see high performance computing, as a matter of fact, to be used over more into the geographical information systems. That could be one use case where GIS and those part could be used. The other are also the socio-economic part of it, where high performance computing will be used, like the tourism area itself, and then the socio economic part, the non yeah. I think what you mentioned actually is a possible, but right now I cannot actually figure it out where exactly does it fit it.
Okay, well, that makes sense, and we're growing and learning and working toward more and more of it, right? So we're still, I think we're still, would you say we were still in the early days on all of these things, right?
That's very true. That's at least in AI, we're in very early days. What's coming up in 30 years or 40 years or 50 years back? Yeah. But I think that's going to be like remarkable. Yeah, and yeah, okay. So on Johannes, yeah, I do have question. So yeah, I mean, like, while you formed this and your experience over, previous long experiences of various fields of technology fields and other aspects of non-technical areas also. Um, where do you see the balance in the future generations coming when you're talking about like collective intelligence? Would collective mean uh, that's going to be using the tools or technologies, or would that collective also mean just the collectiveness that among family members, the people who are less using technology to a less level? How would that cater into? I mean, like, the whole idea of what we're talking here is artificial intelligence. There are also people who do not know about artificial intelligence, yet will be affected by it. I
Yeah.
mean,
That's true. I think that actually everyone, will be affected by it. I think, fortunately or unfortunately.
yes.
I think that we have to really focus on the ethics. So I think that something that has no ethics, it can be clever in certain ways, but intelligent, no. Because I think intelligence is actually predicated on ethics, right? So if you know how to do things, but you don't know what to do, then what are you gonna do, right? So if you don't know what is the right thing to do or what is the wrong thing to do, and this is actually tricky. This is not always so straightforward, and maybe there are multiple right things to do and multiple wrong things to do, and you don't really, it's hard to distinguish between them sometimes because it's a dynamic world. We're living in a dynamic world. You do one thing, you think it's good, and then it has side effects and all of these things. So we need to apply AI for that as well. We need to find out what are the side effects, what are we affecting, how are we affecting it, and then we really have to tune into because also ethics is a very diverse thing too. It's not one ethics for everyone, right? So everybody has a bit of a difference in how they think things should be. And ideally, AI would serve people on a very personalized level, sort of on their ethics. So there are of course illegitimate ethics. They're not legitimate in the sense that if your ethics is to kill someone because they're whatever, or if your ethics is to subdue women or something like this, those are not really legitimate. They are actually considered illegitimate ethics. You might have an ethic like that, but it's not really. It's just not legitimate in the sense that it affects others. So if your ethics only involve yourself and things affecting you, then everything is legitimate, right? So it's because it's up to you what you want to happen to you and how things should affect you and how things should even interact with you. But what is not up to you is how things affect other people or how other people should be affected, right? So that's right. Up to them in a way. So can we build AI that is personalized in that sense? Now, of course, there is as Noam Chomsky correctly said, I often refer to him in certain questions because I think he's analytically quite he has a quite powerful mind. And so one thing he said about language, which is that we have languages, different languages, but there is a bound around them, right? So there are certain things that can't be a human language. And similarly, there are certain ethics that can't really be human ethics. They're not really within the bounds. So it's not as arbitrary as it seems. So people think ethics is completely arbitrary because people have different ethics. There are differences, but we have to understand that these differences are actually probably less than the commonalities that we have. So there is this big commonality that what we generally tend to find as the right thing to do. And if it's straightforward like that, we should always do the thing that everybody thinks is right? So that includes AI. And if AI is distracting us and causing us to hate other people because you see, if you're optimizing, so this is a very important thing. So when you're asking this question about AI, one thing to recognize, I think, is that most artificial intelligence applications are built for businesses at the moment. It could be different in the future, but as long as it's true that it's for the businesses, you have to align your business model. That means the way that you make money with your ethics directly. So if you're optimizing something like engagement, you often have a problem because nothing is more engaging than a racist coming into the room, for example. It's engaging, not necessarily positively engaging, but it is engaging in the sense that you will pay attention to them. And so when you maximize engagement, what happens is the algorithms will automatically push those things that are more engaging in that sense. So they will increase racism in the network because people will react to it. And that's what you're causing then. And then you're drawing some people. Some people will then be attracted by this racism, and you're actually creating more racists. So this is actually something that I think we have to be very careful that this is just an example. What I just mentioned is not the only thing that we worry about is racism. But what I'm saying is that what is really a general rule is that you want to align your business model, how you make money, with what you think is the right thing, and not just you, but the people who are affected. So this is a second step, right? So what you have to, the ethics that your system should be based on is the ethics of the people affected by the system. And Wonderful. Then you align your business model with that. So in a way, you engage all the stakeholders, all the people who are affected by your algorithms, and you're trying to find out what is their ethics, and you iterate on it as well. Did we really hit the nail? Did we represent you correctly? Did we give you the ethics you wanted? Yes or no, right? And over time, we can learn from people what they feel hurtful and sometimes we might make bad mistakes and bad things happen. That shouldn't kill the whole enterprise of AI or digital culture, or we shouldn't then say, oh, this whole thing is bad because something bad happened. We have to correct for it, and we have to correct for it immediately. We have to be open with it, it is a mistake to fire someone for showing that, this is what happened at Google, for example, right? There have been several cases of people pointing out really bad situations that happened with the algorithms that wasn't really maybe it wasn't anyone's point to make these bad things happen, right? They were unintentional. But then when someone points them out, please don't fire them. Let them help you improve the problem and actually point it out, be open with it, public, say, oh, we found that these things are happening that are bad in our system, and we are now taking these steps to correct for them. That creates trust, and then creates a better system and a better society. So I hope I answered your question. I mean, this is I could write a whole book about it. Actually, I'm working on something along those lines. But I hope I answered it satisfactorily for this.
Yeah, that was a wonderful insight that you just said. I very much agree on that part.
Let me just ask you if you could give the listeners and viewers at home a bit of a takeaway. What should they walk away from this conversation? What should they think about? What is the word of the day from you? And it's like maybe an inspirational statement or something of that sort.
For me, I think in terms of use of tools, where we are currently is no previous generations had access to technologies that we right now have, and we are the most fortunate people on earth that we have such technologies, and we can cover large audiences in pretty much in few seconds or few minutes. So while these tools are there, these tools are actually the tools that we will be using even right now, and even in future. And these tools will actually be the ones that will let us know where we're heading further in terms of uh, well-being of people, well-being of the society, the collective intelligence you said or not. So these tools are actually very important, the tools we will be developing in future. The high performance computing systems, the artificial intelligence itself, these all technology are going to converge or merge at a level where we will be using a lot of data, a lot of insights, a lot of intelligence work, and then bring forth that 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 sort of intelligence to the market, or that sort of solution to the market, to the people, that will be oriented to catering for the well-being of the society or the well-being of the nations. So right from what we discussed in terms of use cases, whatever it is, so when we're talking so much on the artificial intelligence, the data, the collective intelligence, I think it's time that we should be more focused on bringing uplifting the humanity or the well-being, and not focusing on the world, not focusing on investing much on the on the security part of it, where like the weapons or the ammunitions or sort of things, but on the humanity side, right? So I think that should be the whole idea. And like we should also develop or look into the tools um, where the way we have devised for outer engineering, like the whole technology that's outer engineering, we should also start looking ourselves within the nature of us, within our own self, what we are, and then that would also mean inner technologies or maybe inner engineering itself, since we have so much of outer engineering already. So I think those use cases where we talk about inner engineering and the outer engineering merging itself and bringing that fact or bringing that to people will serve to the humanity or people's well-being the best. I think while HPC we talked of various areas, um, we should not forget the very well-being or very society that we came from, our own nature, and how we can leverage that into technology and bring that intelligence forward for us and for the generations upcoming years. I think that's the whole takeaway I would like to provide from this conversation.
Fantastic. I love it. So then let me just one more thing, and that is if audience members, people who are listening, people who are watching want to know how to keep in touch with you and how to follow your research and your work, where should they look?
Surely, you can always look into LinkedIn, my LinkedIn profile, and then you can always write to me at Umesh, UMESH at HPCNepal.org. That's my email address. You can find me on Facebook, Instagram if you go by my name, Umesh Upadhyaya. And you might see some mountains or some pictures and then you'll find me there.
This show is published every week on Wednesday at 2 a.m. in Los Angeles, 5 a.m. in New York City, and 10 a.m. in London. Next week, I will be speaking with Giselle Velarde, and we will be speaking about her up-and-coming book, The AI Era, among other topics, such as data science, AI, and particularly AI and music. Please leave your thoughts in the comment sections if any of these topics interest you. Also, please let us know what your thoughts are about AI and music. Should AI make music? Should AI make art? How about the metaverse or the blockchain? Please let us know about all of your thoughts that you may have about the topics that we cover in this show.
Ada Lovelace, who's the first programmer, she thought that analytical machines could create or could be used for any complex task, including creating music. So she envisioned the capability of intelligent algorithms to create music. That was interesting, that also she related artificial intelligence with music.